If you work with OpenCV frequently, you've probably used imread. But how does imread really work? Let's go into the docs and find out. Okay, so I'm in the docs and I'm looking at imread. Okay, loads an image from a file, loads an image from the specified file and returns an OpenCV matrix. If the image cannot be read, it returns an empty matrix, and then it lists the following formats that are supported. But I want to focus on what does it mean when they say returns an OpenCV matrix. Really, what does that mean? Okay, so here I have a frog image, which is 32 by 32 pixels. Let's see how we can use imread on this picture. Okay, so go into an empty file, and let's first import CV2. And I'll also import NumPy, and I'll explain why in a bit. But let's start using the function. So I'm gonna make a variable called frog and use cv2.imread, and my file is frog.png. So let me just print this. Let's just print this for now, see what happens. And it looks like that's the matrices that the docs were talking about. But this is a little lengthy. Let's analyze this a bit more. I'm gonna comment this out, and let's print the shape. What is the shape of these matrices gonna be? It's a 32 by 32 by 3. What could that possibly mean? Well, I know the original image was a 32 by 32, but what could the 3 mean? Well, we all know that colors are represented by RGB values, so maybe these are the 3 channels that these represent, but let's actually see what it really means. Okay, let me actually create my own image from scratch so I can mess around with the pixels and check this out. So I currently imported OpenCV and also NumPy. And the reason we're using NumPy is because that's how we're storing the colors. Like the NumPy array is how we're storing the colors. So let me create my image first. So we'll be using our NumPy array, and let's set it all to zeros for now. I want it to be an 8 by 8, and every pixel will have 3 channels. Okay, and I'm just gonna make the type an unsigned int for now. Okay, should be good. Okay, let's set some pixels. Okay, let's set the first pixel to. Okay, so we know that pixels are stored as RGB values, right? So this should be red because I'm setting the R to its max potential, right? Let's see. Here, I just copy pasted some code really quick so I can display my new image in a window. Ah. Whoa, wait, that's not red. Hold up one second, something's not right. Okay, I'm back at the docs, and I'm reading the notes, and I see in the case of color images, the decoded images will have the channels sorted in BGR order. That is very unusual. I wonder why they would store it in that way. Okay, so here I have a quick script that goes through the pixels of the frog image, and I'm using a CSV file to log the current row, column, blue channel, green channel, and red channel, just to see what it looks like. Okay, so let me open the CSV file. And as we can see, there are a lot of numbers to work with. And going back to my point of why we are using NumPy here, OpenCV uses NumPy arrays to store images because NumPy is implemented largely in C under the hood with some C++ components. This makes numerical operations extremely fast. Even though we write Python code, the heavy computations like array slicing and arithmetic run in compiled code instead of Python loops. This is crucial in computer vision because an image or a frame can contain millions of pixel values, right? You saw how many values were used for like just a simple 32 by 32 image here. And filters or frame analysis often need to process every one of those numbers. So using NumPy allows OpenCV to apply these operations efficiently, and this makes real-time image and video processing possible. Now that we understand how images are stored as BGR matrices and how those numbers are processed efficiently, The next step is to start transforming them. From here, we can apply filters to images like this frog, things like grayscale, blurring, and a lot more, all by operating on the same NumPy matrix.